Hey guys, let's look at this problem on Leetcode. Find all duplicates in an array. Right. So we have given an array, and in this array, the numbers are constrained from 1 to n. Some elements appear twice, and others appears only once. Right. So we need to find the elements which appear twice in this array. Okay. And one of the constraint that is, can we do it in order n runtime and without any extra space? So let's just see this input here and see what essentially is going on with this example. So we can see that the numbers are constrained from 1 to 8, which means 1 to n, but 2 and 3 are the duplicates here. But these actually are replacing some of the numbers from 1 to n, which means 5 and 6 are missing numbers here, right? Now, if we were to do in a name algo 1, we can just construct a hash table, put elements in the hash, put elements in the hash uh, while iterating, and if there is a conflict, uh, that means we have found a duplicate element, right? But we cannot use a hash table because we cannot use order and space, or actually any space for that matter, any extra space. So whenever there is a constraint on the numbers from 1 to n, there is a slight indication that the numbers can be mapped on the index or the indices of the array, right? Keep this in mind. And there's another indication that we can also uh, do something with bits, or we can set bit somewhere, and basically if we have n size array, then we can just set we only need n by 32 bits to represent this n number if the numbers are constrained. But we cannot use the bit set approach here, so we'll go with the index approach actually, because we do not want any extra space. So we see that the numbers can be mapped to indices because they are constrained from 1 to n, right? So what we will try to do to solve this problem is, we'll just try to map each of the number and place it on its index. So if we were to take one based index here, uh, 2, 3, 4, 5, 6, 7, 8, then we what we want to do is, we want to transform this array and compare it with this index. So we want to transfer this 4 onto its original position, right? So what we'll see is, if there are duplicates like 2 and 3, then somewhere along the algorithm, we will try to replace 3 on its original position 3, and it would have already been there. Hence, we can be sure that 3 is a duplicate, right? So let's go run on this algorithm. So we take 4, right, and we put it into its original position, which is here, and we swap the 7 and we bring it back on the first index, right? So we do only this if 4 was or not originally on its position, which means there is no 1 here, there is a 4 here, right? So what we'll do is, this array will become something like this, right? So we have successfully placed 4, right? Now we again need to check whether 7 is on its place or not, but not. 7 is on index number 1. So we'll place 7 on its original 7th index and bring the number from there on this index, right? 7 here and 1 here. So we have successfully placed 7, right? And same with 3. We compare 3, it's not in position, so we place 3 on its index here. And we continue doing that, right? We place 2 on its position. Now here's the conflict. Now, when we want to place 3 in its original position, we see that the number 3 already exists on that position, right? So which means 3 is a duplicate here. So what we can do is we can mark 3 as a X and add this duplicate in our answer. So duplicate found equals to 3, right? And what we'll do is this X actually represents that the 3 could have replaced either 5 or 6 in this original index array, right? So now we don't need to process X. We can move on to 2 because we know that X is a duplicate. So we now are pointer to 2 and we compare this 2 on its original position. Yes, it is. Now we again move this to 3. Yes, it is on it is on the index. We compare 4, it is on the correct index. We compare 8, no, it is not on the index. So we'll put 8 on the index and bring that number here, right? Successfully placed 8, right? Now we need to compare this 1 and need to replace that on its original position, which was here. So replace 1 here and bring x here, right? So we have successfully placed 1, right? And as I said, x can be any number, which means we don't need to process it. So we increment a pointer here, right? So now we check whether 2 is an original position or not, which is not. We try to swap 2 with the index 2 number, but we see that 2 already exists there. So what we'll do is, which means we all again found a 2 as a duplicate number. So we mark that as x and increment the pointer duplicate found equals to 2, and we increment a pointer to 7, and which means 7 is actually in our position. We increment to 8 and 8 is already in the position, and we are done, right? So let's code this. And equals to length of nums, right? We need a iterator I equals to 0. We also need an answer to return, which is a list of the duplicate found elements. We return this answer, right? Now while I is less than n, um, now few things. Whenever we find a x, we increment the pointer, right? So uh, we can just try that, write that condition here. Whenever nums of I is equal to x, which we will assign later, increment I, right? Else if if the number is already on the correct index, right? So if nums of I is already on the index, which means index I plus 1, because it is one based index, correct index placing, we again increment because we don't need to process it, right? Now everything else, which means this case where number 4 was on index 1, we need to swap this number, and we also need to check whether there already exists a 4 on the index 4 or not, right? So what we'll do is, if so first of all we'll take a j, which is a temporary variable which will represent the index we need to overwrite on or swap with, right? If nums of j is equals to nums of I, right? Which means we have found a duplicate. Found duplicate, right? Then nums of I becomes x, right? And we also need to append this in the answer. Answer dot append nums of I, right? If not, if they are not equal, then we need to swap them. Swap them, right? So what we'll do is nums of I and nums of j is equals to nums of j comma nums of I. So we have swapped them, right? And once we make this x nums of I, we can actually increment the counter I equals to I plus 1, right? So let us try and run this code. And wait, there is a wrong answer because we are actually put the comparator operator here instead of assignment operator. Okay, let's run this code again. Okay, let's try to submit this code. Okay, great. So the runtime seems to be order n because we are just placing uh, the numbers on the correct index one at a time, and we are not using any extra memory for doing that besides answer variable which we uh, return as our actual answer containing the duplicates. So yeah, thanks for watching, guys. Subscribe to my channel. Comment if you want any particular question to be solved online. Yeah, thanks for watching again, and ciao.